Hi folks, it's Mr. Robeson here. This is regular statistics. We are working on histograms today. We'll learn how to describe those graphs and talk about their skew and their medians as well as their means. So first up, what is a histogram? So we looked at this in class a little bit the other day. It's similar to a bar graph. If you notice, here's our histogram down here. It's got all these bars. Here's a bar graph over here. It's got a bunch of bars as well. Right. What's different is that the variable for a histogram is numerical. So like these are test scores. So this bar here between 80 and 85 counts the number of tests that were scored between 80 and 85. So it could be 81, 82, 83, 84 and a half, who knows? But it's just, we know that the number is between those values. All right, so since it uses a number for its variable, we call that a quantitative variable. And it counts the frequencies of occurrences of those data values in each of these class widths. So each of these little sections, like 100 to 105, 95 to 100, and so on, each of these are usually called a class. Sometimes they're called a bin, but usually class is what I'll use. So they can call them bin widths or class widths. So each one of these should have the same width, right? And what's different is the bar graph is these were categorical variables. So this is some sort of category we're fitting into, but we're still counting frequencies on the side here, just like we're counting frequencies here. All right, so if we want to make a graph that counts the number of people with each color of hair, which would be best? A bar graph, a stem plot, a histogram, or a box plot? Well, if we're using color of our hair as our variable, that is categorical. It's a category. It's a label. It is not a number. So that means the best graph to use for that would be the bar graph. All right, so if we're using a categorical variable, not a number, we're using our bar graph. All right, now if we wanted to make a graph of the ages of teachers at Oakland High School, which would work best? A bar graph, a histogram, both, or neither? All right, so now we're looking at the ages. That's our variable. All right, that is a number, so we can call that quantitative. So if our variable is a number, we often want to use a histogram there. I mean, we could also use a stem plot. We could also use some other plots. We could use a box plot. We could use a dot plot. But a histogram would be best out of these two. All right, so mean versus median. So one of the things we're going to talk about today is where is the center of the graph. So these are both measures of center. Where's the middle? All right, so the median, you might remember from earlier times, other math classes, is the middle number in an ordered list. Think of the road. Like the median is usually like the little middle part of the road where they grow trees and stuff. There's my tree. And here's one side of the road. Here's the other side of the road. Here's the median in the middle. Right? So the median is in the middle of a list of numbers. Right? The mean is the average. So usually when you think of average, we're doing the mean. We're summing all of the numbers, we're adding them all up, and we're dividing by the number of values that we have. All right, we'll go into actually doing this with a list of numbers later. I just want you to know what they are here for the graphs. So with histograms, we can estimate which bar or which class contains the median by counting the data values. So we're just going to find which bar is it in. That's it. We don't have to find exactly what the number is, just where it is. The shortcut to do this is if we have n numbers, we do 1 plus n and divide it by 2, and that gives us where the median is, the position of it. So this number here, the n plus 1 divided by 2, is not the median, it's just where it is. So then we'd have to count the data values in bars to figure out what bar it's in. All right, so for instance, if we had 25 data values, to find the median, we would do 25 plus 1 divided by 2, so that's 26 divided by 2, so that'd be 13. So that would be the 13th data value. Whatever bar has the 13th data value is where the median is. All right, so what we're going to use now to compare the mean and the median is just we want to know which one's going to be bigger. All right, and we can do that by the shape of the graph. So we have graphs that are skewed right, skewed left, or roughly symmetric. All right, so if it's skewed to the right, remember to the right is that way, that means it has an extra tail off to the right. So for instance, this graph, it looks like it goes up here and comes back down here. It's symmetric. Like this part matches. The left side and the right side are completely matching. But then we've got all this other stuff over here. Right? So this here is my tail off to the right. Right? So that means this is skewed to the right. So we've got this normal graph, nice normal graph right here. If I just kind of round it off, and then we have all this extra stuff over here. So we have this extra tail off to the right. That makes this skewed to the right. If it's skewed to the right, the mean gets pulled up. All right, so the higher values up here, like these big numbers up here, are going to pull the mean up. The median, though, is still the middle number. So the median is going to stay in the middle. So the mean becomes greater than the median. If we're skewed to the right, the mean is bigger. All right, if we're skewed to the left, that means we have the tail off to the left. So here's our data. We're going up here, down, up, and then we've got this tail over here off to this side. So here's our tail off to the left. All right, our highest value is way over here, and then we've got some other stuff way down here. We do have one little data point over here, but that's not like a lot of data. We do have a lot of data down here off to the left. The mean will be pulled down. The median will stay up wherever it is. So the median is going to stay probably somewhere between here and here. The mean is going to get pulled down this way. All right, and we're just telling this by the shape of the graph. So we're just looking for where's this extra little tail. And if it's on the left, the median's being pulled down to the smaller numbers. If it's on the right, the mean's being pulled up towards the bigger numbers. All right, now the other type of graph we can have is roughly symmetric. So the left side and the right side match. So these sides are matched. Like if this was a mirror right here in the middle, this would match with that, this would match with that, this would match with that, this would match with this. This guy is exactly symmetric. All right, so the mean and the median are both going to be right in the middle, and they're going to be exactly the same here. All right, this data over here, though, it doesn't exactly match. But we have that the median is 87, and the mean, the average, is also 87. So they're both somewhere in this bar right here. All right, and we have some data on this side, and we have some data on that side, but they're both about the same. So we wouldn't call this one symmetric, but we would call this roughly. So it's not exactly symmetric, it's roughly symmetric. This one is symmetric. This one is perfectly symmetric as far as we can see. All right, but that just means the mean and the median are going to be the same. All right, so describing graphs. Oops, too far. One too many. There we go. Thought I had a box around this, but oh well. So when we describe graphs, we cuss and BS. All right, so we're going to cuss and BS in this class. All right, and you might notice that the CUSS is all capital. That means it stands for something. The C stands for center. We basically want to know where's the median, where's the mean, is one bigger than the other. All right. U, unusual. Is there a gap somewhere in the graph? Are there outliers? Most of the time this will be no. A lot of times when we're working with histograms, that won't have anything to do with anything. Shape, S. Is it symmetric? Is it skewed right or left? Is there one mode? In other words, is there one highest point? Are there two modes? Are there two bumps? So bimodal will be a bump and then another bump like that. Right? Is it a bell curve? We can talk about that later. Uniform means it's flat all the way across, basically, like that. A bunch of different bars, but they're all about the same size. I should probably label this bimodal. All right. Spread is the other S. How spread out is it? So we can calculate the range, which is the biggest number minus the smallest number. All right. For the histogram, we don't have the numbers, but we can guess. All right. We can use something called the variance. We can do something called the standard deviation, but we don't know those yet. Or we can just say what's the smallest number to the biggest number. Like this would go from 1 to about 50. And make sure to include context. So if we see a title, price of t-shirts at various websites, that's going to be our context. So let's try this. Let's try and describe this graph. So we start with C, our center. All right, so to find our median, we want to know how many data values are there. So we've got 20 in this one. Looks like 21 here. And look, I'm just guessing, but this is 10 here. This is 15 here. We're closer to the 15. I would say that this is probably 13. I would say that this is probably 8, and this one looks like 4. So if we add those up, so let's see, that's 41, 51, 54, 62, 66. So our n here is 66. So to find the median, 66 plus 1 divided by 2. So we get 67 over 2. We get 33 and a half. So the 33rd. So if we just start counting from this end, once we get to here, that's 20 data values. Once we get to here, 20 plus 21 is 41 data values. So we've passed the 33rd. We've passed the 34th also. So the median is going to be in here. All right, so, and this is t-shirt prices. So the median t-shirt price is between $11 and $20. All right, we don't have anything unusual about the graph, so we just write nothing. For the shape, it goes up here. Here's our median right in there, and then it drops and has this tail off towards the right. So we can say that is skewed right. And then I'm just going to make a note that the mean is greater than the median because of that tail. And finally, the spread. Well, we don't know if there's actually a $1 shirt, but this starts at 1. And we don't know if there's actually a $50 shirt. Maybe they're all $45 or $49. Who knows? But we're going from 1 to 50. So the values can go from $1 to $50. Or we can say the range is at most, let's see, 50 minus 1 is 49. So we'd say at most $49. All right, and now we've described the graph. All right, one more here and then we're done. So describing the graph here, so we want to know what's the center. So we got to say, okay, there's 2, there's 3, there's 4 here, there's 7 here, there's 9 here, so that's 16, 20, 25. So our median is 25 plus 1 divided by 2, 26 over 2 is 13th. So we're looking for the 13th data value. We can start from either side. If you start from this side, let's see, we've got 2, plus 3 is 5, plus 4 is 9, and then plus 7 more is 16. We've passed the 13th. It's somewhere in here. So the median, and we've got hours spent playing video games. So the median time spent playing video games is between 15 and 19.99. If you want to call that 20, that's okay. Hours. Unusual, we don't have any outliers, there's no gaps. So like we'd look and see, is there like a gap, is like a bar missing? Then we'd say there's something unusual, there's a gap there. Shape. All right, so we got our high point here, we're going down this way, we've got our tail here off to the left. So we would say that this is skewed left. Don't even have to write a sentence there. We can just say skewed left, which means the mean will be less than the median. The mean is pulled down by these data values. And finally, the spread. Well, we're starting here at 0. We're going to 24.99. So the, let's see, times, we're talking about times here. Times go from 0 to 24.99 hours. If you said 25, that would be okay. Or the range is at most 24.99 minus 0, 24.99 hours. Or you could say 25, that's fine. The at most phrase here is important. We got to have that. All right, and that's how we describe histograms. All right, so next time we'll go over how to make them.